Okay, so far you know how to factor quadratic equations and find their solution. And so now what we're going to talk about is graphing these factored forms. And so here is an overview. Here's the equation of the factored form here at the top. And what you can see, here, let me just highlight it for you so you can see what I'm talking about here. So this guy right here, this is the factored form equation. And what you can see is that we can actually call those terms that we have inside that factored form, we can call them, for the convenience of the discussion, we're going to call them P and Q. All right. So if you were to want to find the axis of symmetry of a parabola, and of course this U-shaped graph, it has an axis of symmetry. It's actually reflected across this point right here in the middle called the vertex. And so we're actually going to find out what that axis of symmetry is, and we can calculate it based on P plus Q over 2. It's actually just the midpoint between the two roots. And so here, I'm going to show you what I mean. So look at number 1 for a moment and just focus in on this equation. To find the roots, we're doing what we've done before. We're going to, the roots being where the graph crosses the x-axis. So for example, right here and right here. That's where y equals 0. And so when I come over to this equation, what I'm doing is setting f of x equal to 0 and saying, well, if f of x is equal to 0, then x minus 1 is equal to 0 and x plus 2 is equal to 0. So that the x-intercepts are x equals 1 and x equals negative 2. So what are the coordinates for the x-intercepts? Well, that would be 1 and 0 and negative 2 and 0. And so now we can calculate what the axis of symmetry is. Remember what we said. We said if we take this term right here, this guy, and we take this guy, right, and we add them together and then divide by 2, we can find out what the axis of symmetry is. That's what AOS stands for. So that would be 1, and we're going to add that to negative 2, and we're going to divide by 2. So what that means is that this one is going to have an axis of symmetry of x equals, this is going to be x equals just a negative 1/2. So that's where the graph is going to have its axis of symmetry. So let's do that again here at the bottom, or on this first example. So here's the graph that we're looking for right here. It's f of x equals negative 2 times x minus 3 times x minus 2. So in this format, the a number is negative 2. And one of the things that we're going to focus on is that the a number really does determine whether the parabola opens up or down. So because it's negative, because the a number is negative, it's going to be a downward, it's going to be an upside down u. It's going to open down. So it's going to open down for sure. And the axis of symmetry, well, we can calculate that just based on this factored form. We can do 3 plus 2 over 2. So that's going to be 5/2, or to make you more comfortable, if you don't like fractions, that's 2.5. And so what we're going to do with this number, okay, that's where this graph has its axis of symmetry. So let's put this on the graph. Just we can put the roots down. What are the x-intercepts? Let's do those. So that would be x equals 3. Okay, based on this, that's x minus 3 equals 0. So that means that x is equal to 3, where y is 0. And x minus 2 equals 0, that's x equals 2, where y is 0. So the x-intercepts, or the roots of the equation, are 3, 0, and 2, 0. Easy so far, right? So let's plot those points. So 3, 0, and 2, 0. Let's plot that. So 3 zeros right here, and 2, 0, that's right here. Okay? Easy so far? Those are the roots. And then let's think about that axis of symmetry. What we're saying with the axis of symmetry is that's where the graph kind of has its let me just draw it right here. I'm going to zoom in quite a bit. It's going to go through this axis right here, this axis of symmetry. And let me actually just use a shape here. I'm going to do a line right through here. See if it snaps in. Okay, so this is the axis of symmetry, what I've just drawn. That's 2.5. And so, it doesn't seem like it's too helpful just yet. But what you're going to see is that if I take this number, 2.5, and I were to stick it into the original equation, whoops, let's not do that. Let's do this instead. Okay, if I were to stick that number, 2.5, back into this original expression and solve for y, I could find the vertex. And the vertex will be the highest point in this graph because it's a downward facing, it's an upside down U. We're going to find this point at the top of this downward facing U. We're going to find the highest point, the maximum of that downward facing U. And so this is how we do it. Put the 2.5 in for x. So take this number and put it in for x, where x is. So when we do that, we get -2 out front, and we get 2.5 minus 3, and then we get 2.5 minus 2. So let's just do this math. So here in the center, that's going to come out to -0.5, right? -0.5. This -2 is still out front. And here, 2.5 minus 2, that's going to come out to, let's see. This is going to come out to a +1/2, right? And so now when we do a -1/2 times a +1/2, we get 0.25, and then, let's see. So 0.5 times 0.5, that's 0.25. So that's -0.25. When you multiply that by -2, you get a +1/2. Okay, so this is now a +1/2. That's what it comes down to. So there is a point on the graph, 2.5 and 0.5. That is the vertex, or the maximum value of this graph. So let's plot that. So on the x coordinate, on the x-axis, it's 2.5, which is right here. We already indicated that, right? That's, let me grab the highlighter again. So that's right here, right? That's 2.5. And then on the y-axis, it's 0.5. So let me zoom in quite a bit more, and just we'll mark this right here, 0.5. So this is 1, and so 0.5 would be about right here. So this is our vertex right here. That's 2.5 and 0.5. So this is what the graph looks like. It opens upside down, and it goes like this through these 3 points. And so that is how you graph an equation in the factored form.